Introduction. Probability refers to possibility. It's a branch of mathematics that deals with random events and numerical description of how likely they are to occur. The value is expressed as a number between 0 and 1. The higher the probability, the more likely an event is to happen. We are going to do some experiment related to probability, which is rolling die. This experiment will show the concept of probability is applied through the practical example of rolling a die. By analyzing this experiment, we can do calculation of probability for simple events such as rolling an even number and odd number. The objective of this experiment are: first, to record the frequency of rolling an odd and even number of a die. Second, to find the experimental probability of rolling an odd number and the number more than 4. To find the theoretical probability of rolling an odd number and a number more than 4. To calculate the percentage difference between experimental and theoretical probabilities. Last one is to determine mathematical expectation involving mean and variance. The table shows the experiment result of rolling 36 times die. So as we see, we have a number 1, we get a 5 times, number 2 we get 7 times, number 3 we get a 4 times, number 4 we get 6 times, number 5 we get 5 times, and the last one is number 6, we get the higher of outcomes, which is 9.
From our experiment, we analyze the result of all the dice rolls. The number that appeared the most often in our experiment is number 6. This means that compared to all the other numbers, 6 was rolled the highest number of times. Next, we calculate the experimental probability of rolling the number that appeared most often, which is number 6. In our data, number 6 appears 9 times out of 36 rolls, so the experimental probability is 9 over 36, which is simplifies to 0.25. Now, let's look at the experimental probability of rolling an odd number. The odd number on a dice are 1, 3, and 5. We count the frequency of these numbers and the total frequency is 14 out of 36 rolls. So, the experimental probability of getting an odd number is 14 over 36, which is approximately 0.389. Next, we calculate the experimental probability of rolling a number more than 4, which is either 5 or 6. The total frequency is also 14 out of 36 rolls, so the experimental probability of rolling a number more than 4 is 14 over 36 or about 0.389. Now, let's compare this with theoretical probability. Theoretical probability is based on what should happen in theory, assuming the dice is fair. There are 3 odd numbers out of 6 possible outcomes. So, the theoretical probability of rolling an odd number is 3 over 6, which is equals to 0.5. Finally, the theoretical probability of rolling a number more than 4, which is either 5 or 6, is 2 out of 6, which is equal to 0.333. Now, let's compare the experimental probability with the theoretical probability. For a fair die, the theoretical probability for each number 1 to 6 is always 1 out of 6. But when we did the experiment, the results were not exactly the same. This happened because of random variation and also because we didn't have a very large number of dice. With fewer rolls, the result can be a bit uneven. That's why some numbers show up more often than expected while others appear less frequently or didn't appear at all. So, the experimental probability can be different from the theoretical probability, especially when the sample size is small.
3.2 Question for Experiments 2. A. The duration x in hours required for the data packet to traverse a network link is characterized by the following probability density function given as f of x equals k multiplied by x squared minus 2x plus 2 for x greater than 0 and less than or equal to 3. F of x equals 3k for x greater than 3 and less than or equal to 4. Otherwise, f of x equals 0. To find k, we use the fact that the integral of the probability density function over all real number equals 1. The integral from 0 to 3 of k multiplied by x squared minus 2x plus 2 plus the integral from 3 to 4 of 3k is equal to 1. This becomes k times the expression x cubed over 3 minus 2x squared over 2 plus 2x. Evaluate from 0 to 3 plus k times the expression 3x. Evaluate from 3 to 4 equals 1. Next, find the probability that the data packets have the duration between 30 minutes to 210 minutes to traverse a network link. First, we start by calculating the probability that the variable falls between 0.5 and 3.5. This is given by the sum of two integrals. The first integral is from 0.5 to 3, where we integrate the function 1 over 9 times the quantity x squared minus 2x plus 2. The second integral is from 3 to 3.5, where we integrate the constant value 3 times 1 over 9. For the first integral, the antiderivative of the function is 1 over 9 times the quantity of x cubed over 3 minus 2x squared divided by 2 plus 2x. We evaluate this antiderivative at the upper limit of 3 and subtract the value at the lower limit of 0.5. For the second integral, the antiderivative of the constant is 1 over 3 times x, which we evaluate from 3 to 3.5. Substituting the limits into the first integral, we have 1 over 9 times the quantity 3 cubed divided by 3 minus 2 times 3 cubed divided by 3 plus 2 times 3 minus the quantity 0.5 cubed divided by 3 minus 2 times 0.5 cubed divided by 3 plus 2 times 0.5. For the second integral, we have 1 over 3 times the difference between 3.5 and 3. Simplify these expressions. The first integral becomes 1 over 9 times the difference between 6 and 1924, and the second integral becomes 1 over 3 times 1/2. Adding these together give the final probability, which is 161 over 216. Based on study, we can conclude that during experimental probability, the chances of getting even numbers and odd numbers when rolling the dice is different in every trial. For this study, we have recorded the outcomes for 36 trials. The probability of rolling an even number, which is 2, 4 and 6, is 11 over 18. Theoretically, the probability of rolling an even number is 3 over 6. The probability of rolling an odd number, which is 1, 2 and 3, is 14 over 36. Theoretically, the probability of rolling odd number is also 3.6. For question 3.2, the value of k is p 0.5 less than x less than or equal to 3.5 is 161 over 216. The value of variance is 1081 over 240.